Okay, so in the last video we did products as sums or differences. Now we're going to do sums or differences as products. So this is how we started off. So we let the sum of two angles equals x, the difference of two angles equals y. So if I add those two numbers together, these cancel out, so we get 2a equals x plus y. And so one of the angles equals x plus y on 2. And instead of adding, if I subtract it, I end up with b equals x minus y on 2. So this is how I'm using it. So I've got, from the previous video, we've got sine cos equals half sine the sum plus sine the difference. And we've just said that a equals x plus y and b equals x minus y to give me sine x plus sine y. Okay. Or, rather than having that, if I double both sides, I have sine x plus sine y equals twice sine x plus y over 2 cos x plus y on 2. So this is how we use it. So for instance, if I want to add those two numbers, now on my calculator, I know the answer is 1.2247, but we're going to try to get our answer not as a decimal, but using exact values. Okay. So these ones will normally end up being exact values, which means you've got surds involved. So we've got sine x plus sine y equals 2 sine, add the numbers, divide by 2, cos of add the numbers, divide by 2. So 75 plus 15 over 2, 75 minus 15 over 2 equals 90 over 2, 60 over 2 equals 45 and 30. And then on your exact values, sine of 45 is 1 over 2. Cos of 30 is root 3 on 2. The 2's cancel out, so you end up with root 3 on root 2, and then you just rationalise the denominator, end up with root 6 on 2, and root 6 on 2 is also equal to 1.2247. So we have a sum that ends up being a product. Okay, so again, these ones you'll just be copying into your cheat sheet, and let's look at the next ones. So I haven't bothered to go through all of them doing it the slow way, but basically we've got, so the first one was sine plus sine. Now we've got sine minus, cos plus, and cos minus. Okay, so if you just copy those in, and we'll see how we go with some examples. Okay, come across when you're ready. Okay, so we've got our first one, which is cos minus cos. So again, just go back. So cos minus cos equals minus 2 sine add sine difference. So equals minus 2, just check it again, sine the sum, sine the difference, sine the sum, and it was a plus sign in between, no, it's a multiplied sign in between, sorry, sine the difference, which is minus 2a. Okay, so we've got minus 2 sine 8a. Now that minus sign can come out the front and become a plus, and then that minus and that minus make a plus. Okay, so we've turned a sum or a difference, and we've turned it into a product. Okay, come across when you're ready. Okay, so we've got to show that that long question there equals tan 3 theta. Okay, so we can see that the question's got 3 thetas in it, and some of our numbers have got 3 thetas in it, so we've got to get these two to come together. So what we're going to do is, in the first line, we're going to put sine theta plus sine 5 theta together, and then we've still got sine 3 theta at the back, and then we've got cos theta plus cos 5 theta, and we've still got cos 3 theta at the back. And now we use our stuff that we've just been doing. So when you've got sine plus sine, you end up with 2 sine 3 theta, because we had to add them and divide by 2, and cos subtract them and divide by 2, which would be minus 2 theta, which I'll come back to in a sec, plus sine 3 theta. Okay, so on the bottom I've got 2 cos 3 theta, cos 2 theta plus cos 3 theta still to go. And then we've got 2 sine 3 theta. Now that number's still going to be a plus. And we've got 2 cos 3 theta, cos 2 theta plus cos 3 theta. So what's common on the top? We've got sine is common and cos and cos. So end up with sine 3 theta, 2 cos 2 theta plus 1 over cos 3 theta, 2 cos 2 theta plus 1. So as long as that number doesn't equal 0, because then the denominator equals 0, I can cross off those two. So sine 3 theta cos 3 theta equals tan 3 theta, which is what we were trying to prove. So equals the right hand side, and so we finish with QED. So all this stuff here was the left hand side being simplified. Okay, and that's it. Thanks for coming.